Welcome to Brain Vision.
Now here this is asking for a lot of the wave properties. We have a mass of 0.650 kilograms, and then we know that x equals 0.25 sine of 4.7 t, and then we can say that this is going to be equal to the general equation a sine of omega t. So for part A, when they're asking for the amplitude, this is simply going to be 0.25 meters. So simply this term right here. And then for part B, where they're asking for the frequency, well, the omega, the angular velocity, is going to be 2 pi times the frequency, and this is known to be 4.7 radians per second. So essentially, the frequency is going to be 4.7 divided by 2 pi. So this is going to be equal to 0.748 hertz. For part C, we have the period. The period is simply going to be equal to the reciprocal of the frequency. So this is going to be equal to 1 divided by 0.748, and we have a period of 1.34 seconds. Now for part D, they're asking us for the total amount of energy. So the total amount of energy is going to be equal to 1/2 mv max squared. And so this is going to be equal to 1/2 m omega a squared. And we can solve 0.65 and then 4.7 times a, so 0.25, and then this is going to be squared. So we have a total amount of energy equaling 0.449 joules. And then for part E, they're asking us for the kinetic energy when x is going to be equal to 0.15 meters. So we can say that the potential energy is going to be equal to half of kx squared. This is going to be equal to 1/2 of m omega squared x squared. And we can solve. Omega here is 4.7 squared. And then x is, of course, 0.15 squared. And we have a potential energy stored of 0.162 joules. Now to find the kinetic energy, we simply take the total energy and subtract the potential energy. So this will be 0.449 joules minus 0.162 joules, and we have a kinetic energy of 0.287 joules. So this will be our final answer for the kinetic energy when the spring is compressed, or rather at x equaling 0.15 meters. And that's the end of the solution. Thank you for watching.